Hello everyone. So we have seen already the SRTF in the preemption method, which is have the similarity with the shortest job first. Now we are seeing LRTF, that is longest remaining time first, which is a preemption method. So that means an interrupt occur. That means any other processes may come while the current running process is getting run. So this is similar to the LJF, that is longest job first. So let's see the numerical in this. Please see the Gantt chart carefully. Always we assume that the arrival time 0 and process is running from the 0th arrival time. Okay, now you can say that is there any process arriving at 0th time? Yes. So P1 is arriving. So we'll write 1 unit of time only. In a previous problems of the non-preemption method, we'll directly write the burst time for the process. But here the main thing here we have to know is it is LRTF or SRTF. We are using only 1 unit of time because at this point of time an interrupt occurs. That means any other process may occur in between the current running process. So we use only 1 unit of time. 1 unit of time. So we'll make it as 1. At 1, is there any process coming? Yes. P1 is there and P2 is there. Okay. Now in P1 and P2, the burst time is higher at which process? At P2, the burst time is high. Yes, so it is longest remaining time first, where we have the similarity with the longest job first. You will see the more burst time as the higher priority. So we'll write here P2. So it will complete its 1 unit of time. So it becomes 4. Sorry, 1 unit of time means 1 plus 1 is 2. At 2, is there any process coming? No. Only P1 is there, P2 is there in the ready queue. So now you see which burst time is more in the among these two processes. P2. So again we'll write P2 and its burst time will become 3, and we are using 1 unit of time, so 2 plus 1 is 3. At 3, any process is coming? No. So arrival time is not there for 3. So again P1 and P2 are there in the queue. What is the burst time? So P2 has a higher burst time. Again we'll write P2. So 3 plus 1 is 4. 1 unit of time is running and it becomes 2. Okay, now is there any process is arriving at the fourth second? Yes. What are those? P1 is there, P2 is there, and P3 is there. So among P1, P2, P3, which has the higher burst time? P3 has the higher burst time. So we'll write P3 here and we'll take it as 5 and we make it as 2. Okay. At 5, at 5 point of time, is there any process coming up? Yes, P4. So P4 is coming. Now we'll compare from P1, P2, P3, P4, which has the higher burst time. So which has the higher burst time? So higher burst time is for P2, P3, P4. But now we will see the arrival time. So arrival time most commonly, see, first thing is higher burst time. If burst time is equal for any processes, check arrival time which have the lesser arrival time. So lesser arrival time is for P2. So we'll write here P2 and we make it as 6 and make it as 1. Next, so P1, P2, P3, P4, which have the higher burst time, P3 and P4, same burst time. But what we'll take? P3 because its arrival time is lower than P4. So we'll take P3 and we make it as 7 and we make it as 1. Now again 1, 1, 1, 2. Which are the higher burst time? We have the P4 as a higher burst time. So we make it as 1. So here it is 8. Now all have the same burst times. So now we will take which have the lower burst time, that is P1 which is 9 and P2 which is 10 and P3 which have 11, and P4 which have 12. So if we have original burst times, we'll make it as 12. And now you will write the completion time, turnaround time, and waiting time. Okay. So completion time and turnaround time. So for P1, the completion time is 9. For P2, it is 10. For P3, 11. For P4, it is 12. Turnaround time is completion time minus arrival time, 9. 9 minus 0, 9. 9, 7. 12 minus 5, 6, 7. Okay. 9 minus 2 is 7. 9 minus 5 is 4. And 7 minus 3 is 4. And 7 minus 2 is 5. So in this way, we'll solve the problem of Lrtf. So if you have any doubts, please comment me in the comment section. I hope you understood. In the next video, we'll see the most important problem, that is priority scheduling. And in the upcoming next video, we'll see the round robin. By this, we'll complete all the scheduling algorithms.